Hey everyone, this is Mr. Postma, and I'm going to be going through your chapter review so you can watch this to try to better understand what's going on, and it can kind of be like I am there all the time to help you. So we will start with question 1. Why is the equation, or what is the equation of the graph shown? So we're looking at this graph at the right. You can see my mouse. The answer is going to be C. First thing you want to notice is with these equations, the y-intercept, if you plug in 0 for x, right, that'll be 0 squared, that becomes 0. 0 times anything is 0, so we are left with 4, which will be our y. So we know for all these equations, when we plug in 0 for x, if we're looking over here, we want our y to be 4 because our y-intercept is 4. So the two equations that do that are the ones that are plus 4, so A and C. So we know that the y-intercepts of A and C are going to be 0, 4 here. And then our next thing we got to know is, okay, how can we figure out the other way? Well, we can try to decide, does it open up or down? So if we look at A, we know that our A value, ax squared, is 1/2, so that is positive. When it is positive, this parabola is going to open upwards here. So it can't be that one because it's opening downwards. So the only one left is going to be the negative 1/2 because we know when our A value is negative, it's going to point downwards. Therefore, it's going to be C because our y-intercept is 0, 4, and our A value means it's going to point downwards. All right, so now on to number 2 here. So number 2, what value of A would make the graph of f of x equals ax squared open down? So we know that a graph will open down when our A value is negative. So that means the tail ends right here are going to point down when our A value is negative. Therefore, it can't be C or D because those are both positive. If A was 0, the whole thing would be 0. So the only thing that does that is a negative value of -8. So we know A will be -8. All right. Next one, does f of x equal negative x squared minus 2x minus 2 have a minimum or maximum? And we need to find the value. Okay, so we can do the same thing with our A value here. Since A is negative, we have that negative sign. We know it's essentially -1. We know that it's going to point downwards. So if the ends of our graph point downwards up here, we think of it like a mountain, and that means that we are going to have a maximum. So right away, we can cross out B and D. So we're going to decide, okay, is it C or A? So there's two ways you can do this. You can use your x equals negative b over 2a formula, get your x value for your vertex, and then plug it in, or you can use your calculator. I like to use the calculator, so here's the steps here. So make sure you have your calculator out right now. So the first thing you're going to do is you're going to plug the equation into the calculator. Boom, step 1. So you're going to plug in this negative x squared minus 2x minus 2 into your y equals button. So I would hit that y equals, I would plug these values in, and if I'm going too fast, don't be afraid to pause the video. So I'm going to plug in negative x squared minus 2x minus 2 into my calculator. Once that's plugged in, I'm going to hit graph. Now, if you can see that max and min, you're going to be good to go and we can do our next step. If you cannot see the max and min, you're going to have to hit the window button, which is the button right next to the y equals button. If you hit that window button, you'll have to adjust your y minimum, y max, x min or x max until you can see that max or min. Okay, so now if you've got that max or min, go back to our graph, we can see the max or min. You're going to hit second, which is that blue button, and then you're going to hit trace, which is right below calculate. So it's going to be second trace, which means calculate, and you're going to scroll down to maximum, right? You're going to hit enter on maximum. So if you hit enter on maximum, it's going to ask you for the left bound. That means you just got to use those arrows there to move the cursor to the left of the maximum, and then you're going to hit enter. When it asks for the right bound, you're going to move that cursor in the top right. You're going to move those buttons all the way until that cursor is to the right of the maximum. Hit enter again, and then that will tell you what your maximum is. All right, so that is the calculator way. That goes really fast once you figure it out. I'm just going to explain that once so we can all understand. If you have questions, come ask me how to do it. So we're going to get that it's going to be a maximum of C -1. All right, so 4 is kind of the same thing. We're looking at 3x squared minus 12x plus 16. Does it have a maximum or minimum? Okay, well, we know our a value is positive. Step 1, a is greater than 0. So it opens up, all right? We're going to kind of look like that. If you're looking at my cursor, it means we're going to have a minimum. So we can use the calculator or the x equals negative b over 2a. I used my calculator, did the same steps as right here, and I got it is b minimum. The value is actually 4. He only had values of 2, so the answers that are on here are actually wrong. So just know that your minimum should be 4 in that instance. All right, so we're on to number 5. Which quadratic function has a vertex of 3, negative 5? Okay, so first we're going to look at our vertex form because that's the easiest way to tell if we have if the vertex is right. So our vertex form is y equals a parentheses x minus h squared plus k. All right, so we know that our vertex is hk, right? And this is the tricky one. So if it's minus h, so like up here minus 3, that means the x value of our vertex is 3. All right, if that's a plus for whatever reason, you got to flip it for that one. It's the only one you got to worry about is this x minus h. Everything else is what you would think it would be. So I'm looking here, okay, what vertex has a value of 3, negative 5? Well, x minus 3, okay, x minus h, our h value is going to be 3 there, so that has 3, that's good. And then we have our plus k. Our k is negative 5, so that's going to be 3, negative 5, so our answer is going to be D. All right, yep, and don't be afraid to skip ahead on these if you get it. Just click ahead. You can, if you got it, just move ahead. So. All right, so we got place the letter of each function into one of the 3 categories. So you should get your notes out for this. Remember, linear is if we add the same number every time. Exponential is generally it grows really fast or it decreases really fast, kind of has a curve to it. And exponential should have the same ratio every time. Quadratic is everything we've been doing with parabolas. So you can check, go through to see if you can understand these. The big one that I want to look at is A. So if you notice A, we look at our y values. So it minuses by 24, and then we get minus 9 and minus 2, right? So if you divide those ratios out, they aren't quite the same, but that is going to be considered a exponential because of how fast it decreases, and for one other reason, which I'll explain in C. So if we're looking at C here, we saw it goes from negative 4 to negative 3. Then it goes from negative 3 to 0 and 0 to 5. Right away, you may think exponential since the numbers we're adding in between are growing at a faster rate. But remember, one of the ways to tell if it's quadratic is that second difference. So we see from negative 4 to negative 3, we increase 1. From negative 3 to 0, we increase 3. And from 0 to 5, we increase 5. Now the second difference means what's the difference between these numbers? So we have 1, 3, and 5, and those are all getting added by 2. So since those are the same, since the second difference is the same, that'll end up being quadratic. For the rest of these, just look what I put here and see if you understand it. If you understand it, we are good to go. And we'll move on. All right, so it asks you to plot the points and then decide if it's linear, exponential, or quadratic. So we'll start at number 7. You can see the plots are pointed here. That's quadratic. You can tell by the parabolic curve. Some reasons we go from increasing to decreasing. Only a quadratic function does that. A common second difference, if we take the second difference of those y values, and then the shape of the parabola. All right. Okay, so for number 8 here, I graphed that. These are in a little bit of a weird order, so just make sure you do these right because it goes negative, or goes x value 2, then negative 1, so it's a little weird. But you can tell by that kind of L-shaped curve, we decrease really fast. That is going to be an exponential, specifically exponential decay. So the reasons, if you divide these values in the right order, we are multiplying by 0.5 every time x increases, and it has that curvy shape. So that will be exponential. Okay, for these next ones, use your knowledge of the quadratic functions to answer each question below, and then we graph each function The biggest portion here is graph the function. A lot of you missed that, so you did all this right, and then you forgot to graph it, and you're going to miss points on that. So don't do that. So I'll go through all these ones. Remember, if you totally understand it, you can skip ahead to what you don't get. So I'll start with 9. Y equals 3x squared minus 3. So does the graph open up or down? It's going to open up because a is greater than 0. So anytime a is greater than 0, we have 3 here, it's going to open upwards. Is it wide or narrow? So remember, the graph is going to increase a lot faster if that a value is greater than 1. So when a is greater than 1, we know it's going to be more narrow. So good to go. And then I'm going to skip this one right now and come back to it. So the next part is another calculator thing I'll show you how to do. And we're going to find the table here, plot the points, and then get our vertex. All right, so the first thing we got to do is we got to enter our equation into our y equals on our calculator. All right, you're going to hit graph, which is in that top right corner. If you're good to go on that and the window looks good, then you're going to hit the second button, hit the second blue button, and you're going to hit graph again. And you'll notice above graph it says table. So anytime we hit the second button, the next button we hit is actually going to be what the blue one says. So if we hit second table, it'll bring up our table, and we can fill in these x values and y values. And we will see our lowest point is 0, -3. If you want to make sure on that, you can do second calculate max or min to make sure that is your minimum. So what I'll say for this, with all these off the top of your head, and this is really important, you could always plug this into your calculator to figure out every single one of these. All right, so anytime you're confused, if you just want to use your calculator and you don't know, the a is greater than 0, blah, 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 off the top of your head, you can always plug it into your calculator and see. Remember, we are comparing to y equals x squared. So we're saying, okay, is it wider or narrower compared to y equals x squared? So that's how we're doing it. So if you understand that and you can do it on your calculator, you are good to go. If you want to understand the a values a little more, I will explain that. Just make sure you don't skip number 11 because that one has an important point. All right. Okay, so y equals 1/2 x squared minus 4. Does the graph open up or down? Well, we see a is greater than 0, so it's going to open up. Is it wide or narrow? So the graph is going to be wide, and that's because a is a decimal, right? So a is 0.5. If a is between -1 and 1, it is always going to be wide compared to the function. So again, for down here, let's plug in that equation into our y equals button. Hit second graph, which is also second table. We'll fill in those values, plot the points, and then we can do our second calculate to find that max or min to find our vertex. Remember, a vertex and a max or min are the exact same thing. So a vertex will always be a max or min. And if you'll notice, so I'm going to bring this up right now. So we get 0, -4 is our vertex. Right now, if you just have ax squared plus c, it's always going to be that y-intercept. Now, it's not always going to be the y-intercept, and that's going to change on number 11 down here. So I'm going to do the same process. Does it open up or down? Well, it opens up because a here is greater than 0. Wide or narrow? A is greater than 1, so it's going to be narrow. I'm going to plug in that formula into my calculator and do second table to get these options here. So these are going to pull up our, our table of values. I'm going to graph that, and one thing you'll notice now is when x equals 0, y equals -4, but that isn't our vertex. So we'll see that is our y-intercept still, but it's not our vertex. So don't get tripped up on that. Remember, the y-intercept is just when x equals 0, because when x equals 0, it's this line right here, right? So this is always, so we got 0, 0, 0, 1, 0, 2, 0, 3. X is always 0, so that's why if you plug in 0 for x, you're always going to get the y value of your y-intercept. So that's our y-intercept. To get our vertex, from our table, we can see it's -7 for y, x value 1. If you want to do second calculate on your calculator and calculate the minimum, you can find it that way too, and that way it's probably a little more precise. All right, on to number 12 here. Does the graph open up or down? Well, we see a is greater than 0, so it opens up. Wide or narrow? We have 0.25 right here for our a value. That is between -1 and 1, so it is going to be wide. And then our vertex is easy on this one because it's in vertex form. So remember, our vertex is h, k, where it's x minus h plus k. So since it's x minus 1, our vertex x value is 1, and then the y value is k, so that's 3. To get these values, you can plug it into your calculator. Alright, so for this one, I'm going to explain it the same way. There's a couple options to do it. So for these first ones, this is vertex form. So this is, I want you to pay attention to number 13 right here. So remember, it's a, so we don't see an a there, so that's just 1. X minus h squared plus k. So we see it's x plus 5. So that means our vertex value, since the original value is x minus h, right? If this was x minus 5, our vertex value would be 5. Since it's plus 5, that is not the form of the original equation, so our vertex value is actually going to be negative 5. I know it's kind of confusing. If you're confused, plug it on your calculator and I'll help you find it. So we got negative 5, and then our y value for our vertex is k. So since it's plus k and it's minus 3 here, it is going to be negative 5, negative 3. Axis of symmetry, remember that is always the same as the x value of your vertex. Since the axis of symmetry, what splits it down the middle, runs right through the vertex. Alright, so we'll do number 14 here. This one's a little confusing because there isn't a k, but we see it's x minus h, but since it's x plus 6, that means our h value is actually going to be, the value for our vertex is going to be negative 6, since this isn't in the proper form, so you have to flip it. So negative 6, we actually don't have a k value here, so that's just going to be 0. And remember, the axis of symmetry is the same as the x value of the vertex. Alright, if you are confused on 13 or 14, remember, you can always plug this into your calculator and go second calculate max or min. The max or min is your vertex, and then the axis of symmetry is this x value. Alright, so for 15, I'm going to go over how to do it by hand. So all these steps, 1, 2, 3, is how I did it by hand. Remember, you can always plug it into your calculator and do second calculate, and that'll tell you how to do it too. But if you want to do it by hand, here's how to do it by hand. So to find the axis of symmetry, we do x equals negative b over 2a. Alright, so remember, anytime we plug in for a value, we need to plug that value in with parentheses. So we see our a value is 4 here, our b value is negative 32, c value is 2. So x minus, I'm going to put in parentheses for our b value is negative 32, so it's going to be negative 32 and then a negative on the outside, and that'll just become a positive, so the top part's going to be 32. We're going to plug in 4 for our a value, so 2 times 4 is 8. So we get 32 over 8 equals 4. Alright, so that means our axis of symmetry is going to be the line x equals 4. So we know that, and what do we also know? The x value of our vertex. So we see, okay, x equals 4, and then the x value of our vertex is 4. To find that y value here, we just got to plug in that x value into the equation and figure out what we get for y, and that'll be our vertex. So I plug in 4 to this equation, so you see 4 parentheses, I put in 4 for x squared, minus 32, I plug in a 4 for x, and then plus 2. So you simplify that out, 4 squared is 16, times 4 is 64, 32 times 4 is 128, and we know that it's negative 32, so we'll get minus 128, plus 2, and we get negative 62. So our vertex is 4, negative 62. Okay, for number 16, I did it with the calculator. So I plug this equation into the calculator, into the y equals button. I hit graph. The window might be a little messed up, so you might need to change your maximum y value you can see, or your x value. So maybe you have to mess around with that window, and then you'll hit graph again. Alright. The vertex, when you go second calculate minimum, is going to be 3, negative 28. And since the x value of our vertex is 3, the axis of symmetry is also going to be 3. Alright, so domain and range. These aren't too bad. So for 17, remember domain is all real numbers. That's because these arrows are going to go on forever. So they're going in that direction. That means these x values are also going to go on forever. So that means we know our x values, our domain, which is what it's asking, the domain is how far left and right does it go, is going to be all real numbers for that x value. Now the range is asking, all right, how high up does the function go? How high down does the function go? And we're going to label that in terms of y. Since this is our y value, and to tell how high up and down it goes, we're going to use y. So we see, okay, this is the lowest it's going to go, which is -3. So y, our y value, can be any value above -3. So we're going to say y is greater than or equal to -3. All right, so for the 18, we're going to do kind of the same thing, domain all real numbers. And now what's our y value? Well, y doesn't go above 2. There's no part of the function that goes above 2, but it does hit 2. So we'll say, all right, this is going to go on forever, so our y value is going to be less than or equal to 2. All right, we're doing good, guys. So we're on question number 19. This is comparing a graph of a function here. So what direction does it go? Remember, for direction, you're looking at the tail ends. Well, the tail ends go down, so the graph goes down. That's the direction. Our vertex, remember, that's where it goes from increasing, boom, to decreasing. So that's going to be the point right here. Remember the max or min of our parabola. So it's a max in this situation. So I'm going to go -1, -2. So x is -2, and it goes up 4 values. So our vertex is -2, 4. It's going to be a maximum here. Obviously, the highest point is a maximum, so it'll be a maximum. Our axis of symmetry is the same as the x value of our vertex here. So we're going to get x equals -2 for our axis of symmetry. All right, now you got to pay attention for these zeros here, because a lot of you flip the values of the zeros. So I'm going to look at this one right here. We see, remember, our zeros are our x-intercepts. So where does it cross the x-axis here? That is the x-intercepts. So we see, okay, it crosses the x-axis right here. So that point is -4 for x, and the y value is going to be 0. Okay, so don't flip that around. A lot of you put 0, -4. That would be this point right here. When x is 0, y is -4. The real point is our x value is -4, our y value is 0, and then if we're looking here, okay, our next x-intercept is 0, 0. The y-intercept is actually going to end up being the same as that second x-intercept. So the y-intercept, where does it cross the y-axis right here if you're looking at my cursor? Well, it crosses the y-axis at 0, 0. Okay, increasing and decreasing interval. This is a little confusing for you guys, but it's really not that bad. So it's asking, okay, for what x values is it increasing and what values is it decreasing? So we see, if we're coming from the left side, the graph is increasing. That y value is increasing. So at what point does it stop increasing? Well, when x is -2. Stops increasing right here. So we could say when x is less than -2, which means when x is from this line over to the left, all the way over to the left, x will be increasing. So it's increasing when x is less than -2. Okay, so now where is it decreasing? Well, it's decreasing every x value to the right of -2. So we'll say the decreasing interval is when x is greater than -2. All right, how we doing? Almost done. So we're on to number 20 here. So the question says the function y equals -3t squared plus 27 represents the height y in feet of a water droplet t seconds after falling from an icicle. It asks, after how many seconds does the water droplet hit the ground? So essentially, if you're looking at a graph right up here, our ground is always going to be when y equals 0. So you can picture that as the ground. So we're asking, okay, when will this function equal 0? So when will the y value equal 0? So one way you can do this with your calculator is just plugging in the equation, and then in the second spot, so if you go to y equals right now, in that y2, if you put in a 0 for y2 in the equation for y1, you could do second calculate intercept, and that'll tell you where that y value is going to be 0. Or we can use our square root one by hand, and this one a lot of you did really well on, so I'd advise you to try this one to get it down by hand. So the first thing we're going to do is step 1, we're going to plug in 0 for y, because we're asking when will that water droplet hit the ground. Ground is when y equals 0. All right, so we get 0 equals negative 3 t squared plus 27. So we got to solve for t now to get the time that it will equal 0. So I'm going to subtract over 27 here, all right, to cancel out that 27. So for step 2, we're left with negative 27 equals negative 3t squared. So to get t squared by itself, I'll divide by negative 3, divide by negative 3, negative 27 over negative 3 is 9. So for step 3, we get 9 equals t squared. Now we're going to take the square roots. So we have the square root of 9 and the square root of t squared. So remember, the square roots are asking, okay, what two of the same numbers can you multiply together to get this number? So the square root of 9 is saying, what two numbers can we multiply together to get 9? Well, it's going to be t equals positive 3 or negative 3. So that's not saying it's 3 times negative 3, because that wouldn't be 9. It's saying, okay, 3 times 3 is 9. Also, negative 3 times negative 3 is 9. But hold on, that's not quite your answer, because it asks how many seconds does it take. So t represents time. Since we can't really have negative seconds, we're just going to say the positive 3 is going to be the answer for this one. So after 3 seconds, it'll hit the ground, and that's going to be your answer. All right. So for the last one here, another vertex question, another max or min question, which a lot of these are. A toy rocket is launched upward from a table that is 4 feet tall with an initial velocity of 96 feet per second. The height after t seconds is given by the function f of t equals negative 16 t squared plus 96t plus 4. So there's two ways to go about this. It's going to ask you for the maximum height and how much time it takes to get there. So really what it's asking you is for the vertex of this graph, because it's asking you for the max. What is the max of the graph? All right, so we find the max of the graph. We can use our calculator. That's our first way. So you could plug into y equals this whole equation. Second, calculate max. And that's going to tell you the height is 148 feet. And the x value is going to be how much time it took to get there, because that's the value we'll plug in for t to get our output of 148. So that your equation is going to tell you it's going to be 148. So the time is 3 seconds. The height is 148 feet. Now, if you want to know how to do it by hand, you can watch this next part. And we're going to use our axis of symmetry formula to figure that out. So for part 1, x equals negative b over 2a. Okay, what's our b value? Well, our b value here is 96. So we'll put in parentheses and plug in 96. So it's negative 96 on top. On the bottom, it's going to be 2 times a. Well, our a value is negative 16. So we'll go 2 parentheses negative 16. And what we're going to get is negative 96 over negative 32. And that's going to equal 3. All right, so that is our axis of symmetry. The reason we know that it's also going to be the x value of our maximum is because the axis of symmetry, which would be right here, is always going to run through our vertex. So that means the x value of our vertex and the axis of symmetry is going to be the same. So we know x value of our vertex is going to be 3. So we get 3 seconds. And then what you're going to do, if you want to find the height, is you're going to plug 3 in for t. And that'll give you the height, y. So we'll plug in f of 3. So negative 16, I'm going to plug in 3 for t here, 3 squared, plus 96, parentheses, plugging in 3 again for t, plus 4. If you finish that out with your calculator and calculate it out, you're going to get 148 feet. And that is how you do the chapter review. So only took 30 minutes. Again, if you have any questions, just raise your hand. I'll come over and help you out. Especially with the calculator, we want you to get the calculator down because that'll save you a ton of time and effort. And if you're going to learn one process, you probably want to do the one that saves you time. So, yep, have any questions, just ask me, and good luck on your test before spring break.